Ooh. This isn't working. Okay. Alright, so I'm just trying to get the, it set my resolution wrong for some reason and now it's sort of cut off, so I'm just trying to get this sorted out. Okay. Right, so why is this like this? Okay, I'll set it back to just the terminal for now, just while I figure this out. Okay, then okay, so okay, so this should be better, right? Let me just look at it in YouTube. Yep. Okay, hey. So, now, let's just get this published now. Okay, so I've got chats, pop out, just so I can see chat, live chat, cool. Alright, now, where's my link? Yeah. Okay. Alright, just gonna find the see, I'll do this bit on my laptop. I just need to post a link to Blue Sky. Alright. still find it really awkward doing just like arbitrary computer things on stream, but I guess this is what it is, and I have to be, I have to get used to this. That, all right, I'm just sort of streaming myself working, and working involves doing like boring things like posting a link somewhere. So. I do aspire to having a smoother way to do this in future though. I don't know why I can't immediately find the link, or ideally get the link before the thing goes live so that I can sort of prepare all of this, but I don't yet know how to do that. Alright, so yeah. Okay, alright, now we can actually get started. So, where were we last time? So, what we're doing at the moment is rethinking what it would be like if we, rebuilt spaCy on PyTorch. So, spaCy was originally built 10 years ago with the previous generation of machine learning approaches. So, when it was first designed, it was built with linear models, which were very practical and actually still have some good trade-offs that, I miss in many ways. And then after that, for V2, we transitioned to neural networks. V3, we transitioned to make the machine learning approaches more customizable and more transparent to users, and also had the option to plug in models that had components built with PyTorch or TensorFlow or other libraries. Since then, the community's really consolidated on PyTorch. It's where all the best models are released, and we're really not gaining anything from the flexibility that we built into V3 of offering a choice of machine learning libraries. I still enjoy the ability to define components of the libraries in our library think, but overall it's not worth it. What we would gain from embracing PyTorch fully is the ability to train models much more efficiently and perhaps runtime more efficiently as well. And we would also strip out a layer of abstraction that's getting in the way. So in our last stream, the approach to sort of thinking through how we would redo this, what would the library look like if we rebuilt on PyTorch, was to imagine a blank slate. Imagine we were designing a new NLP library today. I call it spaCy for SPYCY. That's just, imagine giving it a new name to, to sort of free ourselves up and think about, what this would look like from the beginning. So, yeah, this is. So here's where we got to. We were looking through, what the pipeline would look like, and what we did here was look at the language class that we had in spaCy and think through what methods we would want to keep if we were doing this again. And the main idea behind this is to remove the responsibility of updating and training the components from the language class, which we're now calling pipeline. So in the language class at the moment, we have these methods like update, and then similarly we have various other things for initialization and stuff, because the interface into updating the components goes via the language class. And then the language class calls these update methods on each component. So what this means is that we're not really able to have a single computational graph across all of the components. Each component owns its own model, and because each component owns its own model instance, it would be very awkward and error-prone to then rely on those on object identity between those different models. Instead, we have this, pretty unpleasant mechanism in the library for sharing partial results, which we call like the listener mechanism. So essentially you can have a sublayer of a model which is sort of a proxy that will fetch the tensors from elsewhere and then also pass through the backpropagation callback back up to the source. So what we want to do instead is, if we're going to rebuild on PyTorch, we want to rebuild it so that we do have a single computational graph across the whole pipeline, and this means that so where we got to with this, I think we were here. All right, so we're going to have something like yeah. So this is what we were going to do. So within each component, we can assign them this shared transformer. And so this, when you create the model or create the component, you're going to create it with this shared transformer thing as part of its network. And then, so this will allow components to have shared sublayers. So ultimately, the sort of architecture that you'll have is something like this, where you'll have the tagger is, does something like, transformer, and then, it'll be a linear layer and then a softmax or something like this. And then the parser will also be, it'll want to connect to the same transformer, and then, you'll have some sort of dependency pair encoder, so this is something like a affine model or something like this, and then predictions. So that'll be, some sort of scores over each pair of words for each label, telling you how likely that word pair is to, how likely that arc is over that word, and then some decoder will resolve that into a tree. This is a common approach to dependency parsing these days. It's a bit different from how we do dependency parsing in the library at the moment, but it's a good approach for to make use of the transformer models. And then you'll have other components like this as well. So this will allow having multiple components in the pipeline that reference the same transformer architecture. And ultimately, the single computational graph, the single model, will be will live as an object that that the pipeline has a reference to, and then the individual components will connect to it. So let me see. I think we had some notes on this before. Yeah, notes. Okay. So yeah, these are the notes that I made before on different ways that we could do this. So or different situations that we need to accommodate. So the first situation is the simplest. Every component in the pipeline has a completely separate model. So the tag has a PyTorch model, parser has a PyTorch model, and then yeah, they're completely independent. So they're just different PyTorch models. Then we have this chaining situation where we've resolved that if we're going to at the moment in spaCy, we've got support for this, and this causes us a lot of trouble. Instead, we're going to have this done at the project level. So if you want to have one component that has where its predictions are used in the other one, in order to train such a thing, you have to produce files that have the predictions that you want. So this will make training more fiddly. You have to worry about this thing called jackknifing, etc. But it means that the individual steps can run faster and sort of more independently of each other conceptually. And then finally, the situation 3, which is the one which will be common for transformer architectures. We've got the tagger uses a transformer output from BERT, parser uses the same outputs. So we have to have a model in the pipeline, and then the components can ask the pipeline's machine learning for predictions for their part. And then we have to have a PyTorch God model that does all the work, etc. It's extensible. So, yeah, we want to have something like this in add component tagger, and yeah, that should attach to the main model. So, yeah, what we need to think through is how this works in detail. Like, so, okay, imagine that we've got this model and we get the inputs to it, and then it has, these predictions for that should go to the tagger, that should go to the parser, etc., etc. So let's go back to our model scratch and sort of think aloud through this. All right. So this is our dummy model, but this is, so now what we should have is some concept of like what the master network is like. Merged PyTorch model. So thinking aloud here, so okay, so if we think this through, so this will be constructed by the pipeline. So what we'll have, so imagine we're doing this. Let's see. We've got our front components, and we've got our component models. So actually, it's called front components. All right. So on each of the, so what we're trying to do is produce this single model. Okay, I think we see how to do that. We've got yeah, so let's see. Well, let's imagine this is sort of hard-coded for just a tagger and a parser, because if we can do it for 2 components that we do specifically, then it's easy to see how to generalize it to an arbitrary loop. So let's see, we've got forward and we go self, and let's say from here that we're operating over these documents. So we're going to go transformer, embeddings, so Oops. Okay. And then we'll say parser predictions equals parser model from embeddings. Okay, and then target predictions. Embeddings, and then we need to go and then let's say we're going to return this like this, so we go parser predictions and tagger predictions. Okay, so it's pretty clear how we would generalize this. So we go component name, well, it's no reason to do it in a comprehension, so this for name sub-model and sub-component models. So output name equals from embeddings, and then we return this output. Okay. So if we're doing that like that, then let's see what will this look like when we're actually at the pipeline. So let's see, we've got our forward here, and what we'll do is we would go predictions equals self dot ml dot, I don't know, forward or call something, dot one instead of dot batch or something like that. Okay, so dot, yep, then we'll go for name component in components. We would go component dot use scores or something like this, or set annotations in common parlance in how it is at the moment. We've got doc, and then doc predictions. Actually, let's do it like this. Why am I worrying about this? This is silly. Okay, so we'll just do it as one. So yeah, okay, so right. So what we're essentially doing here is within the machine learning, so we do all of the machine learning once, get all of the scores at once, and then for each of our components, we're going to just call the set annotations on it. So this is in contrast to how we do this at the moment in spaCy. So let's just look at the basic way this works. So your basic approach here is that we call predict over this, and then we call the set annotations here with our, and then this is the part that says, okay, given the, you've run the ML in the prediction part, let's actually apply the scores. So what we're doing here is allowing this to be centralized. So we're taking this prediction part away from the components. So the question is, does this feel sort of annoying? If you're designing a component, how do you do this so that we still want the experience of this, you're writing a tagger or something. You should be able to write how the machine learning works within that tagger. And so we definitely want that to still happen. But we want, when you actually run the thing, it to be sort of taken over and be able to be run by, run centralized as a single graph. So let's all right. 1 second. All right. So yeah, scratch pad here. So we've got this mechanism for that we're running here. We've got this embeddings model, and then what we're promising here is that there'll be this sub-model from embeddings. So let's look at how these models will work. So component model. So just as a quick recap, the reason why it's so important to have a single PyTorch model is we want to allow sort of external training tools or arbitrary training tools to take over the job of the optimization, because there's a lot of these technologies that really take advantage of things like multi-GPU or like distributed training or like any of these things. We don't want to have responsibility for that anymore, because the technologies that we're sort of developing and working with are just not good. These are problems which other people are solving, and especially as models get larger and they want to take advantage of the GPU in better ways, we don't want to stand in the way of that happening. So we want to get out of the way of training the PyTorch model, and that means that we have to get the language class out of that, or the pipeline class out of that loop, and allow the training stuff to access the models directly. In order to do that, they have to be one model. So But at the same time, when you design a component, well, you don't want to design a whole pipeline together. Like the implementation of a pipeline can't be, I implement my pipeline that's like a tagger plus a parser. We have to be able to define a tagger, define a parser, and then allow a pipeline to put those things together. So that's what we're trying to do here. We're trying to, meet those two concerns. So yeah, now we've got a component. It has to make sense to define it as one, but then at runtime we have to allow something like this from embeddings method. So what would this look like? We were going from embeddings, self embeddings. So So yeah, when we design this, we've got, so now this is where I think I'm lacking some PyTorch experience. So let's not worry about this part and imagine what we were doing this sort of directly. So let's imagine that we just designed a PyTorch model. So we go self, and then, let's imagine that we're doing something like this, transformer, and then, I don't know, we do it like this, there was transformer, well actually, let's do this kind of simply, and where's my thing? Alright, yeah, browser. Okay, we'll just transition to this. Alright, so I'm not that experienced with PyTorch, and so it's actually useful to look through just sort of a Gen AI approach to this. Wait, where is this browser that I'm looking at? Transition, yeah, okay. But I cannot find that browser. Or Windows. Okay. Let me just fiddle around with OBS for a second. Browser. This window. Yeah. Okay. Cool. Right. Transition. Alright, except this is weirdly cut off. Hopefully I can adjust that. Browser. Is that better? Yeah, okay, great. Alright, so, chat. Alright, so, alright. Yeah. Do what I fucking tell you, Claude. I told you to take as input, take an embedding model such that transformer is input. Bah. Anyway, I'll complain and get it to rewrite it. This is actually a small general programming tip for writing better code, I guess. As a general rule, if you find yourself instantiating, the subparts of a tree within an init function, that's usually the wrong approach, because it means that you've really taken away a lot of flexibility, and you end up this way, if you want to like control the initialization of those things, you end up taking in all of the arguments to all of those inits at the top of this tree of objects, and then if you want to change some arguments of those initializers, you end up making changes that propagate up that tree of objects. So instead, what you should generally do is each class that takes sort of subcomponents should take those as arguments of the init, and then you have alternate constructors like from blah 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 or from config or something like that provide the convenience of just like creating it all in one, because you do want to allow users to have a method that just like creates your tagger without having to create all of the sub-objects, but at the same time there should be a way to assemble it by itself. And so if you have this previous approach, where's the previous code that we had? Anyway, oh yeah, versioned, there we are. Yeah, so if you find yourself doing something like this within the init, that's usually unideal, and you usually want to rewrite that so that it's more like this, and then it'll be easier to test as well. Because if you have some mock of encoder that you want to have in your tests, you can have some easy, and some easy mock that just like works in some dummy way, or some dummy object for that you then pass in that just behaves like that for the purposes of your tests. All right, so let's look through here. So yeah, we need to call the superclass of the tagger, store the encoder here. Yeah, this is like reasonable options, and then we're going to have this classifier head. Loss if labels are provided. Does that usually happen in the forward function? I think that all right, this is silly. Let's look at the docs instead. Or like just an example here. So yeah, this is fine. All right, how is a human thunders? Blah blah blah. Yeah, this is logical. Like you wouldn't have the loss stuff happen within the class. I don't know why I'm surprised it's actually giving us such whack results. I've actually done this for something that I actually was implementing before, and it performed a fair bit better than this. So yeah. No, I shouldn't have said evaluation for backprop, basically. All right. So yeah. So the basic thing here is that we the tagger model defines these things, and then we do this. So let's see. All right, I think what's going to be a reasonable way to do this is each of the component models needs to define a submodel that works from the embeddings. It's not like there's an alternate way to do this that would be pretty unpleasant and actually similar to the current listeners mechanism, where you say, all right, we allow it to work like this, and then we store as an object on the tagger the pre-computed vectors. And then if you have those pre-computed vectors, then in the forward function, instead of actually encoding those input IDs, we'll use the sort of k-store pre-prepared version. This means that the object invocation, or the class invocation, is only valid if done in a certain order. So it would be invalid to pass in the pre-computed embeddings for the wrong batch, or something like this, and that's usually bad. You usually want a function call to work by itself, without having to call some other function to set state within it. We want it to be kind of a more pure function of its inputs to its outputs, without having to rely on some previous side effect. Okay, so what this would look like is we've got this sort of wrapper component, and then this actually could be generalized pretty well. This would, let's see. So let's imagine that we're going to take our tagger model, right? And this is going to be something that works from a set of embeddings. So model for the tagger components. So I do think components are going to need to know what the actual words are. We do want to have this the signature here. We definitely want to be able to, we want to pass in the documents too. So let's say we've got our embeddings and docs, right? And then going back to our tagger here, I know I'm not setting this well within OBS, etc., but I'm just copy pasting from the thing that was there before. So yeah, let's see. Yeah. Okay. All right. So. Dropouts, blah blah blah, on software anywhere, then torch and import functional SF. This is module, not model. So I think actually we're not going to do it this way. So we won't actually be defining it with this shared transformer. We're going to do this a different way, where we'll have to define the actual model. You're going to define it as though the embeddings are pre-computed, and then there'll be a sort of parent above it that is able to call any of these things from the beginning. And this means that if you do want to provide the transformer instance and run the thing by itself, you have a mechanism to do that, or a class that can sort of wrap around it and do it. But we want to allow this. actually, I guess another approach to this is we could do it like this. So this is fine because it would still be, torch.tensor and then we go embeddings is 1 and socket transformer is not known. Then we can go embeddings is socket transformer. Transformer is unknown and okay, so go and take this. And see that this is with the embeddings object, not a I try to think through these, even these small errors as I'm sort of stubbing out code, just because it helps me see if there's some assumption that I'm making that I'm not. So I try to keep the type checker happy even while I'm doing sort of scratchpad work like this. Okay. So yeah. So this is a totally reasonable mechanism to allow component to allow this tagger to work either from pre-computed embeddings that some shared transformer will have used, or the transformer itself. And we can actually generalize this to say pre-computed layers or something like this. Imagine that we wanted to actually, no, we should have it as really the thing that can be shared between them is some document to vector encoding. I think that it's a totally reasonable sort of assumption, and building in more flexibility than you need and ends up making code worse. It's important to have these sort of pieces where the design is rigid as well as where it's flexible, because that allows the simplicity to sort of propagate through, where you know what you're assuming, and those assumptions let you you can build against those assumptions and build a tighter solution because you know what the constraints are that you need to work with, and you don't need to write code that does things which you don't need it to do ultimately. So yeah, let's keep it as a fixed that the models need to work in two ways basically. So they need to work from a transformer model so that you can run these things independently. It would be pretty annoying if the only way to run these things is by computing the embeddings themselves. I think it's nice if you can allow them to work independently, and we want at least the flexibility of being able to define a component that brings its own embedding approach. We don't want to have the assumption that all the components have to share the same transformer layer. This also means that if you have some architecture like you know, let's say we wanted to have our tagger and have 2 layers of transformer that we, you know, define ourselves or that we compute ourselves. This would work, you know, totally fine within this this architecture. We would just have those layers that we define here, and then we would be running those as well. So okay, this makes total sense. This is our model. It's the tagger component takes batch of documents and optionally the embeddings inputs if embedding is not provided. I think, is my phone ringing? Take 1 second. How do I pause this? Let's go. Let's just transition over to here. Okay. Right, thanks. Yeah, so the chat window wasn't coming up. Okay, right. So let's. Okay, so thanks for that. Yeah, I didn't transition the screen. Okay. I need to master the hotkeys and stuff for transitioning this stuff automatically, or just define it as a screen region or something like that. Is this this approach is not very efficient. All right, and let's make sure I'm looking at the chat. But yeah, thanks for that. All right. So yeah, we're so okay. This makes a lot of sense. We've got our component model. Let's just go a little bit further and go like define the interface of our component model. .module and for a component takes batches of documents and optionally their embeddings as inputs. Encoder must be provided. That's this. And this would be let's just do it as list. Or yeah, stock, and then embeddings will be embeddings and so really this will probably end up being some sort of object rather than just a single tensor, because there'll definitely be situations where we need more. So let's actually take it as a diff of say that. I mean, probably, yeah, all right, let's just say it's like this. So, and then we go like that. And yeah, okay. Where's my type error here? Oh, no, stupid. Okay. Yeah, that's fine. Okay, and let's say this is an instance of component model. Okay, so now let's here we can so now we've got this pretty simple. We've got our embedding model, and now we've got our submodels. So going to go, we can just call our submodel and we go docs embeddings embeddings. Okay, so now let's our forward functions all working here. So that's how we'll run our merged model. And so now let's zoom back out to where we're actually doing this. We've got our single ML thing here, and this, we've got this, and then our ML predictions. So yeah, so predictions is probably a non-ideal word for this. We want we need some name for the the output from the models. That's, well, let's just say component. Now segmentations. Okay. So now, what do we look like when we're actually doing our components, if this is the case? So we've got our call function, but then we've got our predict self, and then this will be a batch of documents. So doc and this will needs to return something like, okay, so we've said that we're going to work with a dict that's keyed by strings and has values of tensors. I think that's simple enough. So if we're calling this, we're actually this predict function. Yeah, so here we're calling the model. It's a question of whether we want to have this. So there's kind of multiple execution modes that we can imagine here. One execution mode is you're going to call the embedding part externally. Then you want to call you want to let the component model run in this forward mode where you pass in the embeddings, but you still want that handled by the component. And then the other one is you want to run it entirely from this. So let's allow that flexibility and say we're allowed the flexibility here of saying embeddings are none. So this is so this predict method is basically a direct exposure of the forward a function of the model underneath. So the question is, why not let people just call that forward function? Well, it's a good idea to allow the components the flexibility of getting in between that, and so exposing making the API for that just like the model underneath, I think is in the long term would be unideal and cause us limitations. So yeah, having this sort of like exposure of it is good. And then the other thing is when you look at the API of some class, especially now that we're all working with entry helpers and stuff, it's unideal if operations of that class are actually operations of the components of the pieces within it. Having some API that's like a bit flatter that just does all of the things for that class is a little bit nicer. So so let's see. I'm going to just go return self dot model dot forward. Okay, so and one dot and then we'll have our set annotations with the self, and then we'll have the stocks, list stock, and then the ML tensor, and this is going to manipulate the docs in place, so it does nothing, it returns nothing. So yeah, then just that, and then so when we're calling a single thing, we're going to say so here we won't actually propagate this. So the question is, do we want to keep this ambiguity up here way through? Let's say no. Let's say when you're calling this, you need to. Well, that's going to be silly. So, and then Okay. This will be a little bit annoying having these embeddings separately. Yeah, well, let's just say it's working like that. So I wonder what if we didn't have these, and in order to call a component by itself, you had to separately call its predict and set annotations. That's sort of shitty. It is better to have these. So it's just awkward having this sort of uncertainty about whether the embeddings are provided or not, propagate up, and now in this pipe method, you're iterating over a sequence. So, yeah, so now we've got this sort of none sequence, which is annoying. Okay, so how do we get sort of an infinite sequence? Or let's see. I know. Yeah, and then this will actually have batching as well. So maybe this is actually an opportunity to correct a mistake that, or something that's annoying in the current implementation in spaCy. The logic about the batching sort of propagates everywhere. So maybe this is also something that we should rethink. So let's see. Let's go to this as well. So yeah, we've got in spaCy at the moment, you have this thing of the streaming and the calling happens like this can be different for each of these components, and this causes problems. And actually, it's an error at the moment to call the subcomponents with different batch sizes because of the listener mechanisms. So having this, and then you also get this problem of like potentially batching things differently. So what we should do instead, like this is a good opportunity to fix this problem, and the components should just work on batches, and the flexibility of handling the batching and stuff in different ways happens at the upper level. So we only work on batches in the components. I think it's docs, this lot. And then this is, and then the embeddings object, it actually represents a batched embeddings anyway. So this is nice. So yeah, let's and then doing this. So going yeah. Oh, actually this doesn't matter, it still works the same. Docs, embeddings, and then selected annotations. Yeah, this, and then this part is yeah. So let's see. Cool. All right. Okay. So, sort of sideline. As a general rule, I like to have methods and functions which either modify things in place or return outputs. So for instance, here the set annotations modifies these in place. Actually, this has to be an error now because this returns docs. But I want to make sure that we support in spaCy components which change the document. Released in this future spaCy thing, because I think that's very powerful at the moment, and it's more powerful than it was before. So having components which is summarization or some other manipulation of the documents, so that you end up with a new document instance, I think is quite a good thing to have in the pipeline. And at the moment we don't. It's a bit murky whether we support it. In fact, the implementation does support it, but at different points we've said that you should keep the text kind of unmodified. And the tokenizer certainly does preserve those things, but through the pipeline, we do support components setting and returning a new doc instance rather than just working in place. So yeah, we'll allow both styles here. So we will, by default, you're going to be modifying these things in place with your set annotations. But, well, actually, I guess this is an abstract method, so it's up to the components whether they work in place or not. So, docs, and then this is going to return just docs. So let's review for a second. What have we, I think it's often good when designing these things to think about where the wins have come from. Like there's a basic sort of conservation of complexity or something like this where, you know, in order to make things simpler in some way, often the way you win that is by introducing some constraints or like, you know, new assumptions. So I think a lot of the win here is coming from formalizing this notion of, you know, embeddings of a document as, you know, a piece of input that the components can take. And I think that that's where we're gaining this advantage. So this wasn't a concept in the original design of spaCy. You know, there were no document embeddings or token embeddings in like, you know, the V0 and V1. And we didn't introduce this as a sort of like regular thing in V2 or V3. And that meant that the support for these pre-computed embeddings had to happen via these back channels and this listener mechanism and such. So by promoting that to a first-class concept, I think we're winning something in the design here and, you know, cleaning some things up. And then as a consequence of that, we're allowing this idea of running the PyTorch model by itself, or like, you know, having a single model by itself. Also by introducing this, the assumption or the design restriction that the shared components of these, the only type of shared input or shared, you know, or reused part between these models will be these embeddings. So that's, so yeah, what you get to share is something that will, you know, assign a token vector for each token, and that's something that, you know, can be computed once and passed between the models. Then the models must, you know, have their own networks that work on top of that, and then we're able, and those models have to be, you know, Torch and N modules, and then we're able to have it work both ways. So now let's think what this would look like. So imagine that we want to run this without the embeddings. That means that you have to do that at construction time at the moment. So when you're constructing the models, you're passing in either the transformer network or the embeddings. So what if instead of this, we took as an argument the transformer model or the output of it? So, so that we didn't have it like this. Where are we? Oh. Yeah. Okay, so at the moment it's like this. You take that as an input argument, and then you run it like this. Instead of passing in these instances, we could instead of passing in this none, we could make that a callable. Yeah, that feels kind of shitty as well. You should be able to construct the object and just like have it work. So yeah, I think that's okay. Yeah, the other thing is we want to allow some components to use the pre-computed embeddings and others not. So you might have some tagger which you've implemented that, you know, you wanted to actually only have its own transformer, and so you're going to ignore those embeddings even if they're passed in. So if you were passing in yeah, well, I guess you could still do that as you're passing in a transformer. No, that would be weird if because if you're passing around the transformer instance instead of this none, that yeah, it would still work either way. But I think it's nice if you can construct the object and just use it as a function as normal. So I do like the idea of taking the encoder as an input there. So the question is, what's the sort of general way to do this? We could allow the taggers and things to always construct things twice. So now, I guess one question I have here is how regular does this forward function have to be? If we had some alternate mode, like does PyTorch call this forward function for us, or are we always in control of this? So this is something where, like, you know, maybe I can ask GenAI some questions about this as well. And this time, hopefully I'll remember to switch back from the browser. I'll be a bit more careful about this next time. All right, so okay. So one thing I've sort of learned with using these things well is I try to avoid asking leading questions because I've found it to be confirmation bias. Like if you tell it sort of your assumption, it tends to want to agree with you, and so you get this sort of confirmation bias. So I find it's better if I'm asking it in a sort of more neutral way. So let me also I just need to move the window around here so that I'm seeing the chat as well. All right. Right, okay. So indeed, we want to make sure that things work cleanly in the call in forward. So let's see, we've got the quarks here, and these are passed forward from forward into this. So we're fine to have like our embedding argument, and then this respects these hooks, forward hooks and backwards hooks, allows like these sort of tracings and stuff. It calls your pre-hooks, etc. So what we don't want to do is have something like this, where we go, I don't know, forward without embedding this. Yeah. We have to support both modes within the forward function. We can't just have some other function that you call. So that's important. So yeah, so the way that we've got this working is fine. So now we've got our component here. It's working like this. Yeah, embeddings and non-embeddings. Okay, cool. All right, this is all making sense. So we're predicting all of our ML here, we're going through here, predict these things. We get our annotations. And okay, so this again, we've got, so now this is the point where I should probably, fix this sort of piping stuff. Alright. So, yeah, this is more opportunity to fix stuff that's messy in space deployment. So let's say dash or something like this. So this is what we're missing at the moment, is this sort of in-between method, which works on a batch rather than working on. So we've got texts. How does that work? I'm always confused about this business with... Oh, it's not so useful. Let's just tell you it's a tuple. There must be some... this is bothering me, so... oh shit, I forgot to transition again. This is so annoying. Alright. So yeah. Yeah. Ah, sequence. Right, that's what I want. Okay. So that's, and then sequence. Stock, then here. Okay. So. And then we go next, set conditions. So actually already we do have a problem here with components that modify the docs, that modify the doc, and in fact we can't really, if we're going to apply all of the ML together rather than over the pipeline, how would it work if some component is modifying the document and modifying the text underneath it? Because the machine learning stuff which we've done before will have applied to the original text, and so this won't work. So we're actually back to this assumption that like a pipeline can't modify the text, otherwise there's no practical way to make it do all of the ML at once, because if you're going to be changing the text, then you need to redo like the transformer and stuff. So let's give up that flexibility again. So yeah, indeed we need this to work by itself. So this is not right. Okay, so we can calculate this text. Okay. Quite narrow this type. I guess I'll just use a cast. Alright, so now full batch, main batch, size text, and we'll have these details about the error handling and stuff to come. But yeah, so this do batch method allows us to simplify a lot of logic here. So, and then we've got text to be still block, and then we go This confuses me. I would think that batch here works fine as a sequence or sequence doc. So I don't understand why I would need to do this. But yeah, spaCy provides this mini batch function. You don't need to worry about that. I guess it's items here. Okay. Well, actually, potentially we want to expose these as environment variables. So I'll just keep them outside. This is the same weirdness. Yeah, okay. Oh, actually, that wasn't the same weirdness. This is quite a reasonable complaint. It's this is supposed to be. Yeah. Okay. All right. Dogs. Okay. This. Right. Doc was to. Still don't understand why this works. So here we go. Okay, we've got an iterable of some type, and then we're going to return an iterable that's a list of those things. So that should be the same type across the two. Where is it? This. Well, maybe this is actually worse than the API, and we should allow mixed sequences anyway. So, let's see. Instead of doing it this way, we'll do it this way. Okay, and then do batch. Maybe we should handle this here. these components. Okay. So okay, so we need to be able to do this at runtime because you need to be able to add components to the pipeline as you go. So let's see, model source So the stuff around having, so this is actually an example from something I mentioned the other day. So last time we were doing this, I was stubbing all of these things out, and I thought to myself, like, God, why am I, worrying about these details and sort of doing this high-level sketch? But what I said at the time was that, you want to keep in mind these requirements that you're going to have, because you need to be aware that you won't think of everything in the design initially, and so like requirements which you're going to have later, you need to kind of keep on the page so that you make sure you don't forget them afterwards. So here we see, as we add and sort of query components and then disable them and stuff in the parent class, we want to be able to do that in the module, in the model. So when we disable, and this is going to extend to like this concept of like toggling components off and on, because we'll want in the model to, if you've toggled off the parser, we shouldn't run that part of the model as well. So this feature set of having, dynamically adding parts and then toggling them on and off as enabled and disabled and stuff is going to filter through in the model, and that's something that it's good to keep in mind as we sketch out the implementation. So all right. So that means we're going to have get, add, has, rename, remove, and enable and disable, I think. So how does disable happens here, so that'll be something that we support in the forward, right? Yeah, okay. So then so we'll have all right. So then why did we do this? Remove. Why is that a tuple? Let's get back into spaCy. Oh, it's a tuple. Look. Maybe I need to take a break. I thought that was like a union. That makes no sense, obviously. Okay. Add model. Okay, yeah, that's fine. Just blah blah blah. Okay, and then. Let's make this a little bit easier. Since this is such a similar API, we'll actually call the internals components as well. Okay. So add has rename remove, and then we've got this disabling and stuff, right? Yeah, disable. Of course, this can't work. Like, how can we have rename without two arguments? Oh, that's confusing. Alright, so this is all making sense to me. When we add a component, you register it with the pipeline. When we do that, so when you add a component, the component has a model, and the component has a name. You tell our master model about this, and then in our forward here, this, so when we call the pipeline model, we're going to calculate the embeddings outside of it and then pass these into the submodels. Then if you wanted to call the pipeline by yourself and you provide it, its own transformer instance, then you could do that so that you can run so that the components can run independently if you want them to. Alright. And then I suppose what we should have as well is like the option of, imagine you had you had a component, you have two components, neither of them want to take shared embeddings. How do we handle that? Should that be discovered automatically, or should it just be a setting on the pipeline? I guess it should be inferred automatically. Alright, 1 second, I need to turn on the lights. Let's think through how this works in more detail with when we're defining stuff. So let's see. So there should be some way of defining in the component whether you want shared embeddings. So, if shared embeddings are available, give them to me. Otherwise, or you can say like, no thanks, I'm good. If you have some component that just doesn't need that, then when we have our pipeline, we want to, know not to run the embeddings or not to bother with that. And it is good if this is dynamic, because as you're sort of assembling the pipeline and manipulating it, this property, this fact about the pipeline, whether you need to run the embeddings, will be changing with that. So we want it to be a computed thing rather than an argument of the whole pipeline. So we need components to tell you whether they need embeddings. Let's, I don't know whether this should be like a subclass you inherit from, or let's zoom back out to our components and think how this should work. Alright, our component abstract base class. We're getting a model here. And then let's see. You know, have some notion of a component. Well, let's not worry about that for now. Just let's see. Model, model. Yeah, so let's make it optional. Now, this is annoying having a one class with the two modes. Let's imagine that we have this separately. So yeah, we've got some separate rule-based component or something that doesn't use a model. Okay, so right, and we want outputs, then dots, and then think of shorter names for these things for now, but let's call this the ML component or model component. Components, then maybe it is better to, as much as it ends up with all of these conditionals, the trade-off with having sort of more classes and more conditionals is always something that, you know, what is this component like? All right. Fix this typo. So yeah, I don't want this. Okay, so we've got our components and they're telling us whether we want to use shared embeddings with them. And to do that, we tell the model needs to tell us whether it needs shared embeddings. So, so okay. All right. And then we'll make this. I wonder whether I make this an abstract class that inherits from. I think I can do that. so this isn't, so we're not doing it that way anymore. Okay, is there some way of making the torch modules generic types? Let me just see. I don't know what this, like, no, I do not know HTML, CSS, and JavaScript. It's like not something that I work on. Yeah, fair enough. Okay, so yes, I can specify the generic types. So that's, so let's see. Let's see, input and output. So yeah, I'm just looking at the PyTorch docs here for, have I been on the wrong, have I had my terminal up this whole time? Ah, wait, no, yes, good. So yeah, good. Got this wrong, good, yeah. Alright, so yeah, let's just see. PyTorch, generic, model. So, okay, input type, hidden type, and output type. What's the hidden type? Are these lies? Let's go back to the code and just try it. But like, but it's telling me that it isn't immediately making sense to me. So let's see. Module, and then we go module and generic. I bet I know what it means. So you're always free to add your own like genericness to these things. It doesn't mean that. Yeah, I mean that's going to be a bad idea. So PyTorch doesn't. So the torch module itself is not a generic type. We could, make our own input and output types, but that's like not going to be good because it won't interact with other people's code properly. So yeah, let's not worry about that. Yeah. Okay. All right. So let's keep moving around our stuff. We're going to have here. Okay. Okay. So Okay, so the next thing to think through, well actually let's fill out this adding and removing stuff just to complete this bit of logic, because it does interact with our models here. So yeah, so yeah, we had our pipeline model, and we've got we know that we've got to do this stuff. So right, yeah. So this will be the same logic to the open spaces, so I should just take it from there. So fine. So. And then should be, so if we're adding it at position 2, we still after equals, yeah, cool. And then, so yeah. Okay. We'll do this here. Oh yeah, okay, that makes sense. Okay. And then we also need to call self-dot pipe. And then here is where, okay, so I've got to remove and add. So that's, yeah, okay. So this is unideal. We can't just call the remove method because we want renaming to happen within the ML. So we can't use these. So and we'll call this okay. All right, this is removed. We need to add let's worry about this disabled stuff now. So the other way that this could be implemented, and I wonder whether it would actually be simpler, is to have a dictionary as a component and then a list that represents the ordering of them. But yeah, no, we'll keep it like this. Wait, hang on. Which is, so hang on, the current, yeah, we're on. I get confused about like the transition, but yes, okay, so this is correct. Yeah, cool. All right, so. Okay. Right. So this is the set, and then this is, yeah, okay. So then components. Okay, pipeline. No, we renamed that to components because the class is called pipeline, so pipeline is not very aesthetic. So yeah, okay. And then active. Yeah, okay, so we call this active components, that's right. Yeah, cool. Pipe names, blah. Yeah, okay, so this is something that this for now. Yeah, we're not using any of these factories for now. Yeah. All right. So next steps, we should think about the serialization. Should think about model initialization and how that all works, and managing labels and stuff. So basically flesh out the rest of the component stuff, just to make sure that the stuff which interacts with PyTorch works, like, that we could get it all working the same way that it did before. And if there's any differences, we want to know about them. So, yeah, okay. Let's see. So that's the spaCy side. All right. Let's see. All right. So let's review here and wrap up for today, basically. So let's see, write ourselves some notes for next time. Should be back on tomorrow, but if I'm not, then we want to make sure that we've got notes for when we pick this back up. All right, we've started up the pipeline, sketched out the component models. Then we have a master model owned by the pipeline. The master model is run once, and predictions passed to the components. Components define their own models. Then when a component is added, okay, then next serialization. Initialization, labels, scoring. All right, so basically next time we'll keep working through the details of this, and we should get to the point where we've got a sort of like, the shell of something we can run. So if it doesn't do, tokenization or just returns like sort of dummy doc objects or whatever, we want to be able to run this sandbox and have, the ability to, to delegate out into these PyTorch models, have them, and check all of this logic of the pipeline that runs a single PyTorch model. Then once we're confident on that, there's kind of two ways that we can go. One way is to start working to hop back to spaCy and put this stuff in place on a branch. So we'll basically have a branch that guts out a lot of the language class to do with the training and that sort of stuff, and puts this in. The advantage of that obviously is we get a spaCy that can start running with these things. I am a little bit concerned that there'll be a lot of functionality which I sort of don't really think about, or that sort of breaks along the way. So there'll be a lot of half-working stuff, which is a little bit, annoying. On the other hand, maybe half-working stuff is, better with a spaCy that, you can drop in and run. The other way is to import the token classes and such into this. And the advantage of that is we can keep working in the sandbox sort of style and think through other changes in spaCy that we might want to look at. Like, for instance, if we're thinking about changing the way that the vocab works in the doc and that sort of stuff, we could keep going in the sandbox. I think probably the best thing to do is to, once we've got, once we're confident in the design of this part, this ML part, I think it's better to go back to spaCy, because otherwise piling on separate orthogonal changes, I think is unideal. It's nice to think it through, and it's fun to work in the sandbox, but I think merging back up and doing one big set of changes at a time is good. So this ideally would then get released as a nightly or alpha sort of build, so that people can try it out, and we can ideally start training some models with it directly. I think I did some work with Modern BERT recently, and this makes me even more motivated to do this, because at the moment the transformer stuff which we've got working, it all has this quite nasty stuff where we have to handle the striding and stuff to handle long sequence lengths. And so there's a lot of complexity in between. This also potentially makes it slower. There's these sorts of things that are unideal. Modern BERT allows sequences up to length 8,000, and this is potentially more accurate as well. So if we just start to implement that length constraint into spaCy as well, and say, all right, it's not as long as you could have documents in spaCy as it is, but once you're at this length of like sort of 8,000, it is reasonable to ask users to do their own segmentation based on the logic of the document. So if it's a long PDF, then you can segment it by section, you can do all of these things. Especially if we introduce some container class for a logical document. Or another way to do it is to have the user or the tokenizer allow these sort of doc partitions. So you've got one doc object, but you've got a concept of partitions that are baked into it, so that we know how to iterate over the subtexts within that doc. So both of those have sort of advantages. I think for simplicity, we'll keep the pipeline for now at a doc object and not introduce this separate thing of a container doc. But yeah. Introducing that length limit and sort of rebuilding a Modern BERT and PyTorch, I think, is very attractive. So I'd like to get this back into, sort of merge this up into spaCy and produce a usable version of this as part of the next steps in the planning. So, but I do want to continue it in the sandbox at least long enough to get something running within this, so that we can have something that we can test and see whether this design works. Which is a lot easier working in the sandbox than it is like, sort of getting it merged up into spaCy immediately and working on a version of spaCy that has to do everything. Especially since in spaCy there's some things if you get them wrong, then you end up with seg faults, right? And those are, unideal to debug. Yeah, if we delay working directly with spaCy for now, then I think that's advantageous. All right, so I think that'll conclude for today. The schedule is that I'll be on tomorrow morning. I know I haven't been so great with keeping up the schedule, but fingers crossed I'm on tomorrow morning at like 10 or 11 or so. So, thanks.